Hello friends, in this AV we are going to talk about selective numericals of ICSE class 10 first chapter of physics, and we are taking the numericals from exercise 1A. To start the numericals we have to know few things. Firstly, we are going to use this formula, that is the formula for moment of force, that is given as force multiplied by the distance, which is denoted as R. And also we have to know the principle of moment, that says at equilibrium position the sum of the clockwise moments will be equal to the sum of anti-clockwise moments. So we look at the first question and we try to solve it. It says the moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. So here moment of force is given as 5 Newton meter, and they are saying that a force is applied which is of 10 Newton. So we have to find the distance R. So as we have discussed, the formula moment of force is equal to F cross R. So we know moment of force is equal to F cross R. So we just put the values. Moment of force is 5 Newton meter is equal to force 10 multiplied by R. So here the value of R, or the distance, is 5 divided by 10, which is 0.5 meter. This will be the answer. Now second question, you can just try using the same formula. You just have to use the same formula, moment of force is equal to F cross R. We try the next question, that is question number 3. It says a wheel of diameter 2 meter is shown in figure 1.28, this figure, with axle at O. A force equal to 2 Newton is applied at B. These are the 2 points, point A and point B, in their directions shown in the figure. So this is the direction of force applied. This will make a clockwise moment. Calculate the moment of force about the center O and the point A. So here we write the given things. Here the distance D they have set in the question to be 2 meter. Then the distance R, diameter is 2 meter, so radius will be 1 meter, radius of this circle. Now moment of force, they have said in the question that a force of 2 Newton. So F is 2 Newton. Now moment of force is given as moment of force is equal to F cross D, or we can write F cross R. This is for the first one. The first part says calculate the moment of force about the center O. So at center O the distance is from B to O, that is the radius. That is radius we have already calculated here, that is 1 meter. So we simply put the values. Moment of force will be, force is of 2 Newton multiplied by distance is the radius, that is 1 meter. So we get 2 Newton meter. And since the direction of force is this way, this will produce a moment of force in this direction, which is clockwise. So we just write in clockwise direction. Then second part of this question, it says the point A, we have to find it here. So the force, the moment will be in this direction again. So it is B, it's going to be clockwise only. So at point A, we have to calculate the moment of force. Again we write moment of force is equal to F into D or R. So that is equal to, now here the distance is from B to A, that is the entire diameter. So force is 2 Newton and diameter is 2 meter. So that is equal to 4 Newton meter, and again in clockwise direction. Now we will try question number 4. It says the diagram shows two forces, F1 5 Newton and F2 3 Newton, acting at points A and B. These are the points A and B of a rod pivoted at point O such that OA is 2 meter, OB is 4 meter, and we have to calculate the moment of force F1 about O, moment of force F2 about O, and total moment of the two forces above O. So here we will try number 4. We'll first write the given things. So here we have written the given things. F1 is 5 Newton, F2 is 3 Newton, OA is 2 meter, OB is 4 meter. The first question says to find moment of force F1 about O. So that is F cross R. Here the force is F1 5 Newton. So we write 5 Newton or 5 multiplied by the distance. Now the distance for F1 is OA. Here you can see that is 2 meter. So 2 meter. This will be 10 Newton meter, and this will be in anti-clockwise direction. Now the second part of the question says that we have to find the moment of force F2 about O. So for this, moment of force F2 about O is again force into the distance. Now force is 3 Newton. So we write 3 or 3 Newton multiplied by the distance is 4 meter. So this will be 12 Newton meter, and here it will be in clockwise direction. And finally the third part of the question says we have to find the total moment of both the forces. So for total moment we will just, total moment is just the addition of the two forces. So this is clockwise, so this will be taken positive, plus the first one is anti-clockwise, that is 10 Newton meter. This will be taken negative, and we have the total as 2 Newton meter. Now let's take a look at question number 6. Question number 6 says the figure shows two forces each of magnitude 10 Newton, this is also 10 and this is also 10 Newton, acting at point A and B, and the separation distance is 50 centimeter. Please take a note that the distance is given in centimeter, so we will need to convert it. Now calculate the resultant moment of the two forces about point A, B and O situated exactly at the middle of the two forces. Now to solve this, we'll just write the given things and I'll do the conversion. So here we have written the given things. Distance is 50 centimeter, we convert it to meter, that is 0.5 meter. What we have to know here is the perpendicular distance of A from F1 is 0. See, the perpendicular distance of A from A is 0, but from B it will be 50 centimeter, that is 0.5 meter. So we do the first part of the question where we have to find the resultant moment of force at point A. So for point A, for the first force, for this one, the force is 10 Newton multiplied by the distance is 0, plus for point B, the force is 10 Newton and the distance from point B is 0.5 meter. So that is 5 Newton meter clockwise. Now for the second one, similarly like this, now the perpendicular distance of B from F2 will be 0 and from A it will be 0.5 meter. So resultant moment of force at point B will be 10 into 0.5 for B plus 10 into 0. Oh sorry, from A. The distance of B from A is 0.5 and the perpendicular distance of B from B will be 0. So again that comes to 5 Newton meter clockwise. And finally they have asked us to find at O, that is the middle point. So resultant moment of force at O will be, now here the distance from A will be half of this and distance from B will be half of 50 centimeter. So that is equal to, the force is 10 into 2.5 plus from B also the distance is 2.5 only. So sorry, it will not be 2.5, 0.5, so it will be 0.25 and this will also be 0.25. Yes, my mistake. Now when you multiply it with 10, then you will get 2.5 plus 2.5. This 0.25 is half of this distance, that is 0.5. So now 2.5 plus 2.5 is 5 Newton meter and it is going to be clockwise. Now let's try to solve number 10. It says the diagram below shows a uniform bar supported at the middle point O. A weight of 40 GF is placed at a distance 40 centimeter to the left point of O. Here. How can you balance the bar with a weight of 80 GF? Now here we will take help of the principle of moments, which says that the sum of anti-clockwise moments is equal to the sum of clockwise moments. So here we have to see that the mass is 40 GF and the distance is 40, from 0 to 40. So distance is 40 here, that is equal to, we have to balance it with a bar, balance the bar with the weight of 80 GF. So 80 GF into, let's say that the balancing point is point X. Now if we solve this, we get 1600 80 GF into X, or X is equal to 1600 divided by 80, 20 centimeter. So if we place the weight of 80 GF at a distance of 20 centimeter, now this weight has been placed to the left, so we will place the weight at 20 centimeter here. At this point we will place a weight of 80 GF. That will balance this bar. Now let's take a look at question number 15. It says a uniform meter rule of weight 10 GF is pivoted at its 0 mark. Now what moment of force depresses the rule, and we also have to find how can it be made horizontal by applying a least force. Now here this is pivoted at its 0 mark. Now to balance it, the balancing has to be done at the center. So here at this point, that is at 50 centimeter, we place the weight of 10 GF. Now what is the moment of force? So the first part, moment of force is equal to the weight, that is 10, moment of force is equal to 10 into 50, that is the distance. So that is equal to 500. And next part of the question says how can it be made horizontal by applying a least force. Now for that, again we will use the principle of moment. So we have 10 into 50 is equal to, now we will take the full length, that is here. Now this has to be at 100 centimeter, and let's say that the force is x GF. So we have 100 into x. So this will be 500 is equal to 100x, or x is equal to 5 GF. Now finally let's try to solve number 17, and that will be all in this AV. It says a uniform meter rule of 100 gram is balanced on a fulcrum at mark 40 centimeter by suspending an unknown mass m at the mark of 20 centimeter. We have to find the value of m, to which side of the rule it will tilt if the mass m is moved to the mark 10 centimeter. Resultant moment, how can it be balanced by another mass of 50 grams. Okay, so let me write the given things first. Now here we have written the given things. Mass of the meter rule is 100 gram. It is balanced by the fulcrum at 40 centimeter. We have to also take the note that center of mass for this rule, meter rule, is at 50 centimeter. So the net moment at balancing point we know will be 0. So this mass m is suspended at the mark of 20 centimeter. Mass of the meter rule is 100 grams into, it is balanced at 40, so from 40 to 50 it is 10 centimeter. Now from here we can find out m is equal to 1000 divided by 20, so that will come to 50 grams. Now the unknown mass is 15 grams. Now they have asked to which side the rule will tilt if the mass m is moved to the mark of 10 centimeter. Now if the mass m, that is 50 gram, is moved to the mark of 10 centimeter, that means towards the left, then it will the meter rule or the meter scale will tilt on the side where m is suspended, that is towards the left side. Now for this balancing point we have 50 into 30 is equal to, 50 is the mass and 30 from 40 it's shifting 10 centimeter on the left, so the distance will be 30 centimeter is equal to mass of the meter rule multiplied by the distance it has moved 10 plus 50, that is the balancing point, into x minus 40. So if we solve this, this is 1500, this is 1000 plus 50x minus 2000. Minus 2000 coming this side will be added with this, so that is 3500. Bring this 1000 this side, it will be minus 1000, that is equal to 50x. So here we have 2500 is equal to 50x, so x will be equal to 50, that is 50 grams. Now this mass 50 grams has to be suspended at the 50 centimeter mark so that we can balance it. So that's all we have in this AV for you. Thank you. Keep learning.